Alright, so let's take a look at finding derivatives of inverse functions. So the first thing I want to remind you of is what an inverse function is. So we can say that square root of x plus 4 and x minus 4 are inverses of each other. If you were to graph those both on a graph at the same time, they would be symmetrical over your y equals x line. And let's see. Let's do a couple examples here. Alright, so you're going to be given a function, and then you're going to be asked to find the inverse, and then the derivative of that, and then you're evaluating it at a certain value. So the first thing we want to do is switch x and y. So we go, x is here, and y is here. So that's the first thing we do with inverses. Normally we would solve these for y, but we don't have to. We can just go ahead and take the derivative of both sides. So we have derivative of x is 1 dx, but we're going to account for that when we do y prime. So we do 2y times y prime. And solve for y prime. So we have 1 over 2y. Okay, so now that we've found the derivative of the inverse, we can evaluate. But we plug the 4 in, not down here at the end, but we plug it in for our x value for the original function, well, for the inverse. So plug in x is 4, and then we have equal to y squared, and then we can solve for y. So square root both sides, we get y is 2. And then we can take this 2 and plug it in down here. So we get 1 over 4. Okay, so evaluated our derivative of the inverse at 4, we get 1/4. Alright, next one. So we're doing the same thing. We're switching x and y. And then take derivative. Solve for y prime. Okay, so now we're taking our 9 and we're plugging it into the x value over here. So 9 equals cube root of y plus 1. So we subtract 1 first. Get 8, and then cube root both sides, we end up with 2. So y is 2, remember we plug that in down here. So 2 squared is 4 times 3 would be 12, so we get 1 over 12. Okay. And then the last one here. So switch x's and y's. So x goes there, y here. And then we take derivative. So 1, we get 3y squared plus 5. And since how both of them had y in there, we're going to multiply by y prime to both. Could be y prime here and a y prime here, and then we could factor it out, or we can just do it in one step. So now we divide by this piece. So we get 3y squared plus 5. Now we're plugging our 5 in to the x. So 5 goes into x. And we're going to run into an issue if we try to solve for y. So what we have to do is we have to graph this. We have to graph this function and 5 to see where they intersect, or we can move over. What I like to do is move that 5 over and graph this. So we're graphing this and seeing what the intercepts are. And if I remember correctly, it is y equals 1. I'm going to go ahead and verify that real quick. So let's see, and we're just graphing with x's even though it says y's. So x to the third plus 5x minus 6. Okay, and we can calculate the 0, but it is 1. So we plug in our 1 to our y. So we get 1/8. So 1/8 would be the answer to this one. All right, and I'm pretty sure that, yep, that's it. Last example. So let me know if you have any questions, and see you later.